This meeting is being recorded.
In the last section, we'll review from Chapter 11, Section 11.7. We're going to review some tips and some ideas that can hopefully help increase your proficiency and your success with solving synthesis problems. So again, we know that to build a molecule, we must be able to choose the right tools for the job. So that means the right starting material, the right substrate, the right reagents, the right steps, also come into play. So sometimes you can, if you do step 2 before step 1, you'll get a completely different product. So we'll look at some examples with practice problems doing that. But we still have these two different rationales or two different considerations to make when we look at our starting material and our product. And we could organize reactions into two sets of reactions. This may be helpful. So we could look at all the reactions that alter the carbon skeleton, so things that form new carbon-carbon bonds, such as with the alkanides. So we lengthen our carbon chain. And then we could also look at shortening the carbon chain. That would be in that category as well. So things like ozonolysis and DMS. So ozone with DMS could also alter the carbon skeleton. Then we could put another group of reactions or create another group of reactions that alter functional groups, such as we have addition reactions that could halogenate an alkene. So let's take a look at some examples of ideas. So we could design your own problem. Right? This is another idea. Besides sorting reactions into different types, those that alter the carbon skeleton, and then those that change or move functional groups, we can also design our own problem. So these are some recommendations. To start with something simple, a simple reactant. Choose a reaction. Write out the reagents, and then predict the structure of the product. So do that, and then you would take that product, and that's your new starting material. Repeat this step a couple more times. And then at the end, take out all of the intermediate products and reagents and just have your starting material and your end material. So your substrate, your starting material, and then your product. So you can swap these with classmates, and then you would have multiple practice problems in addition to the ones in the textbook. So here's an example of how we could create our own synthesis problem. And here we go. So we've created with an alkyne. Oops, there's an extra E in there. So we have an alkyne that we're trying to create into this structure over here. So for this reaction, we start with our alkyne, we have our sodium amide, and then we can add a methyl group with iodomethane, methyl iodide here. So we've added on this additional carbon in our first reaction. Then we look at our second reaction, right? So we're going to repeat step 2 a few more times. We're going to create reaction 2 and reaction 3. So this is step 2 again and again. So we've added another methyl group on this side of our triple bond. So now we have increased our carbon chain by 1 more. So we went from 2 carbon atoms to start to 3 with reaction 1, and now we're up to 4. So now we have this as our starting material, and then if we use Lindlar's catalyst, we know that that will add 2 hydrogens to our triple bond, so we create an alkene, and since it's a poisoned catalyst, Lindlar's, we only have 1 addition, and specifically it will produce a cis alkene. So at the end, you would just remove all the reagents and all the intermediate products and have your starting material, your alkyne, and then your cis alkene as the product. So you might notice that there's often more than one way to solve a synthesis problem. In general, there could be many ways if you don't care about efficiency or, green chemistry, utilizing all of your atoms and not producing a lot of waste. So depending on those factors, you may find multiple ways to solve a synthesis problem. For example, we see this cyclic structure with an alkene side group here. And we could use borane and THF and then hydrogen peroxide in basic conditions and produce this alcohol here. Or we could do an addition, anti-Markovnikov addition specifically, and then in a second step, use sodium hydroxide, and then we would end up with the same product. So you may encounter this, and chances are on an exam, you may see you'll see only one correct answer, but it will usually be the most efficient. That's what I should steer you in the right direction. So you'll see the most efficient synthesis as an answer to your test. So again, multiple ways to solve the same problem, and if you want to create your own practice problems, you can follow these steps. So we'll look at some practice problems with synthesis in order to review.